All right, so here we are looking at some notes. So while we didn't do example three, we did different example. It's going to be the same thing. And so what they had here was they took x cubed minus 3 all over x squared. And so what they would have done in their problem, they would have taken this divided by this, and they would have got the integral of x. And then they would have had a minus 3 times the integral. And then it would have been, because it would have been a 3 over x squared, and they would have said, well, let's do negative 2. And we forgot our dx and our dx. And then when they simplified that, the integral here, that's going to give us what, x squared over 2. The integral here is going to be a minus 3 x to the minus 1 over a minus 1 plus c. And so that gives us x squared over 2 plus 3x to the minus 1 and then plus c. And you could take that x to the minus 1 down and have 3 over x. And that would be fine as well. Or you could leave it like that, and that would be what they would have done. But what they're saying is you can't just say, okay, well, this is going to be x to the 4 over 4 minus 3x over x cubed over 3. That doesn't work. So you can't go from this and then simplify and get that. So basically, in general, basically what they're saying is the indefinite integral of a quotient is not the quotient of the indefinite integrals. So and that's to be expected since the derivative of a quotient is not the quotient of the derivative. So you use the quotient rule and things like that. And so this one, we have to kind of use, divide everything first and then have it into the two integrals, and then we can integrate each one of those. Now, in similar manner, kind of what we did, we had the two binomials. Well, what they did in this one is they multiplied here, and then they took the integral of x cubed dx, and then plus 2 integral of x dx. And so then they got what did they get? They got x to the fourth over 4, and then plus 2x squared over 2 plus c, and then that canceled, and so they get x to the fourth over 4 plus x squared, and then plus a c. So you can't just take and do the integral here, and the integral here, and the integral here. So what they're saying is the indefinite integral of a product is not the product of the indefinite integrals. And again, that's because we have the product rule when we do derivatives. You kind of have to do the same thing. And so in this case, we actually multiply first. And then after that, once we have that, we can split it apart into the sum of two integrals and then do both integrals and then get our answer that way. So you can't do quotients by just dividing, and you can't do products by just multiplying, doing integrals. You have to kind of use the methods that we're showing here that I did in the purple. Okay. All right. So with this one, the power rule applies only really to power functions in the form x to the n, where the exponent n is a real constant, but it can't be equal to a negative one, and the base x is the variable. Now, the function e to the x is the exponential function with a variable exponent x and a constant base e. So this one, you can't just say, okay, well, that's e to the x plus 1 over x plus 1. Well, remember, e to the x is e to the x, and then plus your constant. Now, not all elementary functions have elementary antiderivatives. So it's impossible, for example, to give a formula for the antiderivative of e to the x squared in terms of elementary functions. So nevertheless, finding such a formula when it exists can markedly simplify the solution of certain problems, but we can't do it just like it is here. We can't just say, okay, well, that's e to the x and be done. It's much, much more complicated than that. Okay. All right, so let's look at this problem. It says find the equation of the curve that passes through 2 comma 6 if the slope of the curve is given by dy dx equals 3x squared at any point x. All right, so let's write this down. So we have dy dx equals 3x squared. Well, if we multiply both sides by dx, dy equals 3x squared dx. Well, now think about this. If we take the integral of this and the integral of this, well, the integral of this that's a constant function, so that just gives us y. Now the integral of this, well, we could pull that 3 out and we'd have a 3, and the integral of that's going to be x cubed over 3, and then we'd have plus c. Well, then that cancels, and so we get y equals x cubed plus c. Now, it says it wants it through this point. So that means we're going to evaluate this for 2 comma 6. So we're going to plug in 2 for x and 6 for y. And that means we're going to actually find out what c is. So if y is 6 And 2 is what x is. Well, 2 cubed is what? Well, that's 8. So if we subtract 8, minus 2 is equal to c. And so then that means our y is equal to x cubed and then minus 2. Okay. And so that's what they're really looking for here. All right, let's stop there and we'll come back for some more.